Okay, so real quick with the review of so yesterday we went over this and you guys seem to have had a pretty good handle on this lesson, so this should be pretty smooth sailing on this part. So this is more of a review for you. If I had 12 and I'm multiplying it by 4/4, what would I get? 12. So if I were comparing it, I would just say that it's equal. And we know that because 4/4 is 1. Not because we're working it, but because we know that 4/4 is equal to 1. I don't even want to work it. I just want to do it up here. Now, if you are just surefire determined that you have to work it, fine. That'll give you a chance to figure out whether or not you are correct. But this is one of those things where you can do whether or not your answer is reasonable. Because some people will tell me that if you have 2 feet, you have 20 yards. How many feet make a yard? I know. That's why when you guys get that stuff wrong on your math tests, I'm going, really? Did you do it? Is your answer really reasonable? You should have about this. So how many feet make a yard? How many feet make a yard? 3 feet make 1 yard. So if you only have 2 feet, do you even have a yard?
No.
No, so then you shouldn't have 20 yards. So they would do really weird stuff. So this helps you figure out if your answer is reasonable. Thinking about what you are doing. Well, I know this is equal because I don't need your help. So I know this is equal because, and then you can work it to check it. But this is part of the doing it inside your head that I hate. But I'm not telling you to do the computation in your head. I'm telling you that, is it reasonable? I know that this answer makes sense because. So if I have 12 times 3/4, how would that compare to 12? Would it be greater than, less than, or equal to? Less than. And we know that because 3/4, right, because 3/4 is less than 4/4. 3/4 is smaller than 1. 3/4 is less than 4/4. So if I work this, nine is less than 12. That's if you really wanted to check it, just be sure. Just to be sure. But 3/4 is less than 1. There's 3/4. It's less than 1. I mean, we're proving it right there. 3/4 is less than 1. So if I take 3/4 and I multiply it by 12, my answer should get smaller.
12 times decimal 75.
Not there. But 3/4 is 75 hundredths, so it would be the same. But that leads into the other lesson that we're doing.
more numbers are smaller, less than bigger.
What?
I mean, what I mean by is, if it's 12 times 3/4 8, and the 12 is bigger than that 12, more numbers. Not more numbers, but it's bigger than that number.
I do not understand what you're saying. But maybe, are you trying to say something that's in relation to that?
Yes. Is 12 bigger? Because that.
No, the 15.
Not even trying to work it. Don't even try to work it.
Oh, that's big.
Just go off.
So would this be less than, greater than, or equal to?
Greater
Why?
Because it's
Because this is a mixed fraction, because this is improper, because 5/4 is bigger than 4/4. And I mean, you don't have to work it. And I mean, I know that Etheria remembered it because she was like, because that's 15. Because I did this exact problem yesterday. And she remembered it. So, but also because it's improper. Anytime you take a number or a fraction, whether it's a whole number or a fraction, and you multiply it by an improper fraction, it's going to get bigger. Because it's bigger than 1. Do not go to sleep. Because 5/4 is greater than 4/4. That's why. This is less than 1, this is bigger than 1. So when it's less than 1, your answer is going to go down. When it's bigger than 1, your answer is going to go up. So I did that one. This I want to get to one that we didn't, because you guys are memorizing things. Okay. So what if I had and I'm going to switch them up. Now, the vocabulary that we're using, this right here is what we're calling the first factor. All it is that's the number that we're using to compare. We're comparing the product here to our first factor. Or I'm up here, so quit turning around and looking back there, I'm up here. So that's what we're comparing. This number, 3/5, is what we call the scaling factor. The scaling factor is the number that we are comparing to 1. Is it 1? Is it less than 1? Is it bigger than 1? That's the easiest way for me to break it down. The scaling factor is the number that we are multiplying by the first factor. And is it 1? Is it bigger than 1 or is it less than 1? So 3/5 times 1/2. This product, is this product less than, greater than, or equal to 1/2?
Yes. It's less than.
That's not a yes or no answer. Why?
Because 3/5 times 1/2 is 4.
That's not asking you to solve it.
Because 3/5 is not whole.
You have it, girl. This goes here. She answered it the way I wanted her to answer it. She didn't try to solve it. So you stole my brain. So that's why it's not working. Thanks. You stole my brain, and I'm going to be stumbling around everywhere because 3/5 is less than 5/5. That's the easiest way.
I see it now.
Because 3/5 is less than 5/5, the entire product is going to be smaller than your original factor.
It was that.
I switched them
Really like,
because they're not always going to be in the same order. Because this one right here, since those numbers are the same, the other number is your scaling factor. Oh!
Wait, so you know how you said those first factors where it says 1/2? Are those always going to be the same?
so,
The other number is the one that you're comparing to 1.
number 3.
Yes.
Here's 36. And 36 times 1/2.
I'm listening.
It's because the whole number is bigger than, I mean, that number is less than the whole number. 5/5
I don't know what you're comparing it to.
36 times 1/2.
Is any of them equal to 1? Please stop. Yes, ma'am.
Where did you get the 5/5?
That's because I'm always comparing it to 1. If it's 1, it's going to be equal. If it's less than 1, the product's going to be less. If it's more than 1, my product's going to be bigger.
So like the 1/2 time always going to be 1.
This stuff.
I'm just going to continue. Because I feel quite sure at some point it's going to sink in. My scaling factor
I know you did.
times my first factor. This entire product, comparing it to my first factor, is my product going to get be bigger than, smaller than, or equal to this?
Bigger.
It's going to be bigger. Why?
Because
Because this right here, because 9/5 is greater than 1. Because 9/5 is greater than 5/5. So the entire product is bigger than my original first factor. It's all about this. You're making my hair grayer. Stop it. Oh my gosh. You did. Okay. So here we go with this one. Why am I hearing bigger? Really? Because this right here is one whole. So it is equal because
I'm such a goof.
5/5 is equal to 1. And when you have a number times 1, it's equal to itself.
It's just like one whole times 1/2.
Oh, so if you did it 5 times 1 and times 2, that'd be 5 tenths, so that'd be a half.
But I don't want to do all that work. You don't have to do all the work. It's just taking what you know about the scaling factor. Is it more than 1, less than 1, or equal to 1? You don't have to do the work on these 2 lessons. It's mental math, and you're not even really doing the math. You just, what do you know about this number as compared to 1?
For a second, I thought it was both numbers.
So whatever that
Okay, so I want you to look where we have number 1 And I know that when you read number 1 with the directions, as I told first period, this kind of reads almost like, oh, I'm sorry. I know I am. That when you read the directions for number 1, it almost reads like an ACT Aspire question, because it almost makes you want to, run out of here and cry, and your head spins around, and your eyes roll back in your head. But because it is a very hard set of directions to read. But what I told, one of the test-taking strategies you really should try is, 1, read it all the way through, and then you kind of go, oh my God, what? But then go back and break it down and read one part at a time, just like a word problem, and just do it one step at a time. And I know that some of you do not do that. Some of you do, but some of you don't. So, and you really should. Because if you do, it makes it a lot easier to complete. Because I know that whenever we read something, and I read it to you, you go, oh! And then as soon as you do it, you go, I don't know what to do. And then I read it, and I break it down, you go, oh! And if you would just break it down and do one section at a time, it would be a lot simpler. So, it says solve for the unknown. So you know you've got to solve it. Unknown just means you've got a blank. You need to figure out what goes in that blank. Rewrite each phrase as a multiplication sentence. Circle the scaling factor and put a box around the number of meters. Okay, now stop your head from spinning around. Keep your eyes facing forward. Keep the smoke from coming out of your ears. It's fine. So now what we're going to do is we're going to break it down, do one step at a time. It's not that bad. Now, don't worry about the fact that it's telling you to put, that it's got meters in there. So what? It's still numbers. It's not asking you to do a measurement conversion. It's just talking about meters. So, it's just numbers. Now, whatever you're doing in your lap, stop. Thanks. Not asking. So there was a lesson that we did where they would give you a sentence and you had to write a number sentence to be able to solve. Do you recall? That makes me sad because it actually was this quarter.
Where was he again?
Writing a number sentence.
Oh,
Rewrite each phrase as a multiplication sentence.
I remember.
You have to write a multiplication sentence that goes along with this. Half as long as 8 meters. You have to write that as a multiplication sentence. That's all that means. So how would you write that as a multiplication sentence? What would it look like?
1/2 minus
Multiplication sentence.
1/2 times 4x.
I'm
1/2 times 8.
curious where the 4 would come from. 1/2 times 8. 1/2 times 8.
What about 100?
There is no 100 in here. Are you doing a conversion? Because you're going from meters to meters.
I think she got 1/2 for 4. I thought we doing it.
Because you're thinking the answer. You do like I do sometimes, but you're just writing each phrase as a multiplication sentence. You're taking this and writing it as a multiplication sentence. So, 1/2 times 8. I'm not jumping ahead. I'm doing each sentence, each bit. See, y'all making it harder than it is because you're skipping ahead. And that's why you tend to do things wrong. Because you're skipping ahead and trying to do all of it. Circle the scaling factor and put a box around the number of meters. What's the easiest part to do?
Circle.
Number of meters. What are the meters?
8.
8.
And 1.
So what else? What would be the scaling factor?
1/2.
1/2. 2 would be a denominator. The whole thing would be the scaling factor. So that would be what I would be comparing to 1 if that's what I would be doing in this problem. So is my 8 going to be getting bigger or smaller? Smaller because 1/2 is smaller than 1. So now I have to solve it because it says solve for the unknown. So 1/2 times 8. Multiply across.
9.
I did not ask you. So 1 times 8 is 8. 2 times 1 is 1. Yeah, I know. 8 divided by 2 is 4. So it says, solve for the unknown, 1/2 as long as 8 meters.
I just did 8 divided by 2 times 1, and then I got
Okay. So it's still 4 meters.
I just did the both of those divided by 2.
If I had 8 meters and I had half as long. What's half of 8 meters? 4 meters.
Because he only has 2 is 8.
8 times as long as 1/2 meter. How would you write that as a multiplication sentence?
8 times 1
8 times 1/2. Gee, it's not nearly as long, as hard now, is it?
No.
No. Would you stop it, smartboard?
And then you circle the 8.
Times 1/2. So which one would be circled now?
8.
The 8 is the scaling factor because that's the thing that's making you multiply. What is the meter? 1/2. Now solve it.
8 times 1/2 equals
Still 4 meters.
It's the same thing, but like opposite.
It's the same thing yet opposite.
It's 8 and 2 meters. No, it's 3.
Why are you writing on his paper?
I'll write it.
But he needs to write his own. So on number 2, I'm not asking. I'm telling you, you need to be writing on your own paper. Her pencil does not need to be on yours. I'm not even asking. So your mouth needs to stop writing. So on number 2, it's asking you to draw a tape diagram to model what's going on up here. So if you have basically 1/2 of 8, because the multiplication symbol stands for of. 1/2 of 8. 1/2 times 8. What would that tape diagram look like? No. What would that look like, DeMarco? I know it's a tape diagram. It's telling you to do a tape diagram.
Tape diagram is 8. A hole. Oh,
So,
it had A be separated in 8 parts. 8 over 1. 2 sections. 2 sections, and then you have to put the 8s in. Yeah, okay, that's right.
nope.
Oh, there's 2 sections. 8.
What is my hole up top?
8.
8.
Where's the 8?
How many? I'm doing this one right here. How many sections?
4.
Oh,
So 2.
2 seconds. Y'all started blurting out a whole bunch of weird stuff.
I said 2. I said 2.
And then y'all started doing 8 and 2, and then there's 4 of these.
I
And
meant to like.
yeah.
I said. Or like.
1/2 of 8. Like if I had a piece of wood that was 8 meters long, and I did half as long as 8 meters. A piece of wood that's 8 meters long, and I took half of it.
4. I want the 4. 4.
Half as long. This piece would be 4. This piece would be 4.
Okay, here comes the O. 4. 8. Is that what? Okay.
So 8 times as long.
8 gonna be like, we have to do a half, and then we'll have to shade in too. No, would it be 1/2 at the top and 8 shaded in and the diagram? It's the same thing, but 8 in the square.
8
do a half. And then 1/2 at the top.
Now this one is a little bit different.
I thought you would do like.
The scaling factor is greater than 1, so the number of meters is increased.
I thought it would be opposite. The number of squares would be 8, and then the whole number would be 2. Ooh, good job. And then on the bottom, cause like.
So 8 times as long as half a meter. So each piece, 2, 3, 4, 5, 6, 7, 8. And each piece is a half a meter. 8 times as long as a half a meter.
Would 4 go on top of it?
Yes.
Oh, yeah. So it's supposed to be 9 pieces. 9.
This is 1, 2, 3, 4, 5, 6, 7, 8. 9. Because each one is a half.
Okay, so.
Because if you put them all together, you would have 1, 2, 3, 4, 5, 6, 7, 8 over 2, which would be equal to a total of.
Oh! You're so smart. No, you're not.
That's rude.
Yeah, I know. That makes more sense. What do
So, now number 3 and number 4, these ones are the ones where you really have to have an understanding of scaling factor. Figure out what you're doing with the chair and what you're doing with your jacket. So you really have to have an understanding of scaling factor in order to be able to do 3 and 4. But I think that you guys really do have the understanding, and I think you're really going to be able to do these. Am I sitting on the mouse? I think so. Okay. So you have to be able to, on 3, complete the fraction to make these number sentences true. So 7 times something over 4. So my scaling factor, I need to have something to make the product of 7 times something over 4 to make my first factor of 7. My product needs to be less than 7. So what can I put as my numerator?
4.
Something, it can be 3/4, it can be 2/4, it can be, if I make it 4/4, would it be less?
That would be equal.
If I put 4/4, it would be equal. So it can be 1/4, 2/4, 3/4. But if I go 4/4, it's equal If I go 5 or higher, my symbol switches and it goes greater. So it has to be 1, 2, or 3. Stay away from zeros. I do not want to see zeros. So you can do 1, 2, or 3 as your numerator here. I don't care which one you do. I don't want what ifs. Are you listening to what I'm saying? So 1, 2, or 3, I don't care which one you do. But it cannot be 0, and I do not want a 4 or anything else higher than a 4.
Yes, ma'am.
It has to be a 1, 2, or a 3. So 7 over something times 15 to be greater than 15. What do we need here to make this product higher than 15?
7. No, 7. I mean, no, you 6.
If I make this 7, it's equal to Marco.
6.
So what can you do? So we can do a 6. We can do 5. I see Zach back there is like he's yelled it out twice. So we've got 7, we've got 6, 2, 1. So we can do 6, 5. You said the one number that I said do not do. So we can do 1, 2, 3, 4, 5, or 6. You cannot do 7 because my symbol will become equal. You cannot do 8 or higher
Because it will be bigger.
because this will become less than.
Oh, wait.
So it's got to be something where this will be an improper fraction. This has to be improper because you need it to be an improper fraction.
That one has to be a 5. Has to be a 5.
3 times something over 5 equals 3.
5. Because it's an equal
5. Because you need it to be equal to 1.
Oh, that's
Okay, so I want you to do A and B to make those number sentences true. Now A, the products need to be greater. B, the products need to be less than. Okay, so what kind of fraction do you need on A?
improper.
You have to have an improper fraction on A for your products to be greater. So your numerator has to be bigger than your denominator. So 3/4 times some kind of improper fraction to make it greater than 3/4. Johnny, what did you put for the first one?
6/5. I put 5/4.
That would be improper. I'm not asking everyone to start yelling stuff at me. As long as it's improper. Demontre, sit down.
I can do 5.
Thank you. So, as long as it's improper, your numerator has to be bigger than your denominator. So 2 times something would need to be greater than 2. Braden?
Mr. What it says choose a single fraction to write in all things like something.
Oh, but you know what? I'm fine with y'all giving me 3 different things. Because I'm totally fine with it because I wanted you guys to come up with something different. Stretch your brains a little bit more. Oh, quit whining. Did what?
Yes.
So it had to be improper for this to follow through. And I said that if you couldn't remember, look up on number 3. Because these were greater, and we did an improper fraction up here. The product had to be less than. So we had to have a standard fraction where your numerator is less than your denominator. So 3/4 times something is less than 3/4. Yes, markup.
1/4.
That's a really big 4. 2 times something is less than 2, Jeremy. Take
Me?
No, another big.
I'll put a 4/5.
As long as your numerator is less than your denominator, it would work.
Can we do the last? Oh. Can we do that?
Is related to what we did just a second ago. If I had 2 times 97 over 100, if I were going to compare that to 2, how would that compare? This, would it be greater than, less than, or equal to this? It's less than. And we know that because this is less than 1. Because we have 100 over 100 is 1. 97 is less than 100. So I can also say,
Oh, you can also say
that I can turn this into a decimal.
Oh, yeah. Yeah, you can.
And this is equal to this. And if I have 2 times 97 hundredths, can I also say that 2 times 97 hundredths is also less than 2?
Yes.
Because, for the same reason, 97 hundredths is less than 1. Is it 97 cents less than $1?
Yes.
Yeah, no, there is no kinda. Is it 90? If I have 97 cents, can I buy something that costs $1?
No.
No, because 97. That's not. It's yes or no. Can I buy it? No. If I have if I have 99 cents, can I buy something that costs $1? No. There's no maybe. There is no unless. Can I?
No, ma'am.
No, because 99 is less than 1. Less is less. It may be slightly less, but it's still less. So that's what the next lesson is. It's comparing scaling factor based on decimals instead of fractions.
Okay.
It's the same thing. Whether it's less than 1, more than 1, or 1, because of a decimal. So if I had 2 times that, 2 and 1 and 100, would it be greater than, less than, or equal to?
Greater.
It's greater. Is it greater by much? No, but it's still greater. Because $1 and a penny is still greater than $1. If I had $1 and she had $1 and a penny, she still has more money than I do. It's only a penny. But if I lined them up on a place value chart, 1 is bigger than a 0.
So you had more than one.
Don't make it harder than it is. Because this is bigger than this. That's all you need to know. The product of this is greater than this because this is bigger than that. That's all you need to know. So that we're going to work on a little bit of that when we come back, and it's really just based on with the decimals instead of the fractions. And it's really the same thing, knowing your place value. So, yeah. So how about we not mess with it? 19 and 4/10. This is our first factor. Times 9600. This is our scaling factor. So this is our first factor. This is our scaling factor. I'm going to compare it to our first factor. So my product, how is it going to compare in the long run? Greater than, less than, or equal to. So look at your scaling factor. 96 hundredths. So don't just blurt stuff out. I want you to really think about what would happen. My product right here, what do you think would happen?
It would go down.
Let's see. What symbol would go in here? Greater than? I keep switching my questions, and so y'all really don't know what to say. So I'm going to be consistent with my question. Greater than, less than, or equal to. What symbol would go in here? Greater than, less than, or equal to? Less than. Why?
Because 96 is not one whole. Because 96 is not $1.
Because that makes it really simple, doesn't it? Because 96 is not $1. This is less than $1. I do not have a 1 here. Parker, can you look up here and not worry about whatever it is you're messing with? Because this is less than 1. Trevor, look up. Thank you. This is less than 1. So my product is less.
I thought the 19 and 14 had to be equal to 1.
I'm comparing this and this. Moving from over there. This is the thing that affects it. This is my scaling factor. This is what I'm comparing to 1. If I've got the 1 number over here and it's the same over there, that's not what I'm comparing to 1. It's the 1 number that is not the same on both sides that I'm comparing to 1. Just like when I had my fractions, it was the number that wasn't the same on both sides.
So the first factor can be behind and in front of the.
I would think that maybe why I'm not being sarcastic, but I would think that might be why we're calling it the first factor. Because it's what's in the front. I know, but it's also, we can maybe call it a front factor, or it's a factor that we have over here that we're comparing it over here in the back. I don't know why we give it all these weird names, but the scaling factor is just the one that affects its size. So we have scale that we use on maps. We have scale that we have when we're making models of things. Scale is size. So the scaling factor is changing the size of this. So whether it's making it bigger or smaller. So I'm I'm really trying to find a way to explain it. But this is the only number that we don't see on both sides. This is the only number that we don't see on both sides. Can you agree on that?
Yes, ma'am.
So this is the number that we compare to 1. Not Melanie. Sorry, I was looking at Madeline. Can you stop looking at your phone? So this is the number that we're comparing to 1 because this is the number that is not on both sides. That's the easiest way I can break it down. Does that make sense? Okay. So now it's really close to being 1. It's slightly lower. It's slightly less. Just a little bit. Can you agree to that? Because 96 cents is close to $1, but it's not $1. So it's slightly less. Slightly less. But it's still less, but it's slightly less because this is just a little bit lower than 1. It's only 4 away from being 1. If I had 96 cents, I'd only need 4 more cents to get to $1. 96, 97, 98, 99, 100. I only need 4. So it's only slightly less than being equal. You see where I am with that? Okay. So if I have 19 and 4/10 times 200, how would this scaling factor where are you? There we go. How would that affect it? Would it be greater than, less than, or equal to? It would still be less than, because this is still less than 1. 200 is less than 1. But it's way less than 96 hundredths. Do you agree with that? That's like 2 cents. It doesn't make more sense when I talk about it like money. It does for me. Does it make more sense?
Yeah.
Like money, when you're like, okay, I got 2 cents and I got 96 cents. For me, it makes more sense if I think about it like money. Okay, you're missing the point when you do like that. But if I think about 2 pennies as opposed to 96 cents, I'm really close to $1. This one, am I anywhere near $1? No. So, but I'm still going to get smaller. But with this one is a lot less. So my product for this one would be a lot less than 19 and 4/10. It's less by more than this one. Because my scaling factor is closer to 1 than this one. Yes, ma'am.
So that number is the only number that matters.
I've got a lot of numbers up there. You gotta be more specific than just saying that number. The 200s?
Mhm.
What about
So it's the only number that matters.
in the point of changing 19 and 4/10? Yes. Because it's affecting the size of 19 and 4/10. It's changing how much of this number do I have after I've multiplied it. It's changing the size. And it changed it by a lot. This one changed it by a little, slight, just a little bit. So if I had, just to prove what they're saying, and you see, I, again, am not worried about lining up my decimals. Please don't try. So that's 24, 54, 56, 11, add a row, add a 0, 36, 81, 84, 817. 1, 2, 3. So it only went to 18 and 624 thousandths. So my number got smaller, but only a little bit smaller. So it's only slightly less. It's less, but not a whole lot less. You see how it changed, how it got smaller? Can you please stop playing with the pencils? That's great. Put them down. Thank you. But if I do this one, I do have to include that 0 because it's in between the decimal and a 2. I do have to include this. 8, 8, 3, 1, 2, 3, 1, 2, 3. It made it a lot less. So do you see how your scaling factor, the size of your scaling factor affects your first factor? The size of what you're multiplying your number by really affects your product size. Oh, you're looking right now. I'm like, what are you looking at? You're looking at my computer, sorry. So you see how it can really affect your final product. Do you see? Yes, no, maybe?
Yes.
So now you see why this one was a lot less, because it was really far away from 1. I've got 200, so that's like 2 cents. Isn't that far away from $1?
Yeah.
But see, the whole time I was doing this, you were kind of staring off into space, Marco. So you're not going to get it. I did this whole thing, and you were kind of zoned out, so you're not going to get it. This is way less than $1. So my product is a lot less than what I started off with. I had 9,600. That's really close. So my answer should only be slightly less, and it was. It's not too far from where I started. So you can't zone out on me when I'm teaching this stuff, because you're not going to get it. Okay. What about if you had this is your first factor, and this is your scaling factor. What is going to happen to my 1 and 200ths? Oh, wait. No. Sorry. Now, how do you go from being an eraser to a pen? This is my scaling factor. I just read the problem. This is my first factor. They didn't have it with the symbol and the thing. So is it going to be a lot, or slightly?
Slightly. It's gonna be greater. It's gonna be greater, but just a tiny bit.
Because this is my scaling factor. So is it going, first let's figure out if it's going to be greater than or less than.
It's gonna be greater than, because there's a 1 and then there's that 2 right there.
Okay, so it's going to be, this is my scaling factor, so we already know that this is going to affect the size. This number's on both sides, so we're comparing 1 and 73 hundredths to 1 and 73 hundredths. We know it's not going to be equal because we're not multiplying it by 1. So, but we're multiplying it by more than 1 because we have 1 and 2 hundredths. So our number's going to get bigger. Is it going to get a lot bigger or slightly bigger?
Slightly.
Slightly. Because it's only 2 cents past a dollar. That's just smidge bigger. That's just this much more than a dollar. Now if I had $1.85, that my number would change a lot. But it's only this much more. Not a whole lot.
So if you have $1, since you can't find something for $1, it's gonna be
Scaling factor. First factor. Would it be a lot? Or would it be slightly?
a lot.
So we've already figured that it's going to be a lot.
It's gonna be greater than and a lot because
So-
29 is bigger than 1.
So it's going to be bigger because this is larger than 1, and it's going to be a lot because it's a whole lot bigger than 1.
It's 29.
It's 29. That's a whole lot larger than 1.
You're like,
So we're not always just going to be stuck with 1, and I think that maybe you would ask me that. We're not just doing with 1 and 2, and maybe it was first grade that asked me that. Was it you? Okay, so we're not just sticking with 1. We want 29. So we're not just staying small. You can go bigger than that. Yes, ma'am.
before you said that,
I think we've already disproved this problem. Johnny says that multiplication always makes numbers bigger. Explain to Johnny. Gosh, Johnny.
he doesn't know what 5 times is. Still a child.
Explain to Johnny. But see, we're not just talking about multiplication of whole numbers. Because on the front, we're not doing whole numbers. Explain to Johnny. Give more than one example. And I don't want you to use 0. You cannot use 0 in this example.
Can we use it with what we just did? Can we use it with what we just did?
Now the obvious one, no. Now 1 is fine, but you have to use more than one example. If you decide to go super simple and tell me 5 times 0 is 0, and 5 times 1.
20 divided by 5. It's
Multiplication, not division.
Can we do that fraction stuff you just taught us?
Would that be what's on the front right there?
Yes, we can do it. Alright.
Explain to Johnny why this isn't true. Give more than one example to help him understand. So, help me explain this, Zach.
Okay, this is what I did. I did 8 times 1/2. And for my explanation, I put is incorrect because if I multiply 8 times 1/2, I will get 4, and that is a small number.
Okay, so sometimes
Oh, we can use fractions. Oh, the pen.
So as we proved on the front, sometimes it makes the number smaller. So what if we did
Oh, I know. You were good.
would it be equal to 8?
Yes.
Yes. So sometimes the number what? Stays the same. He says that always makes the number bigger. Sometimes it does. But sometimes it makes the number smaller. Sometimes the number stays the same. It doesn't always make the number bigger. If you multiply by a fraction, it can make the number smaller. Yes, Jeremy?
It's not a question, but can I read what I wrote?
Huh?
If you multiply by a number that is not 1, your answer is smaller. If you multiply by 1, the answer is
A company uses a sketch to plan an advertisement on the side of a building. Is this part of the problem super important? No, not really. The lettering on the sketch is 3/4 inch tall. It's 3/4 of an inch tall. That's probably important. So it's not really an inch, it's almost an inch. Sit up. In the actual advertisement, the letters must be 34 times as tall. So they'll sketch it out on a piece of paper. They'll be like, this is what it's going to look like on the billboard. And they'll draw it to scale. They'll say, this is not to scale. This is where scaling factor is really important. If you're going to be like graphic design, you want to grow up and you want to be in advertising or something, they'll draw it out, like those really cool billboards that you'll see out on the road. They can't bring in a billboard into the office and be like, this is what it's going to look like. And it's like, 100 feet long. They'll have it on a sign. And they have to make the letters smaller. And then when they're going to plan it out, they know that it has to be so many times larger than what it is on the poster. So, first factor, scaling factor, math, man. It's crazy. That's why we use it. Sometimes you're like, man, why do I need this? Obviously, graphic design. Art. We need math sometimes. This is an art major thing. So, if the letters start off and they're 3/4 of an inch tall, in the actual advertisement, the letters must be 34 times as tall. How tall will the letters be on the building? That is multiplying.
3/4 times 34.
So,
34.
3/4 times 34. So each letter is 3/4 of an inch, and you've got to take it and make it 34 times bigger.
Alright, so it's going to be...
So each letter, you've got to multiply it by 34 to get the actual size of each letter. So how about you do that?
Could you just do, since it's 3/4, like you said 3/4, can you just
What did you get?
I got 25 and 5/10, which I simplified to get 25 and a half. I just got 25. Actually, yeah, I got 25 and a half. I got 25. Hey, I got 25.0. I got 25.4.
Okay, so we're getting 25 and 25.5 is 25 and a half.
25.
So you got 25 and then you got 25 and a half. So let's see. Well, you do it your way, I'm going to do it mine. What?
17.
What? 2 times 17 is 34.
Yeah. Oh, snap.
You know.
Oh, snap.
No one's, I'm just working it. Why didn't said you had to do it this way? It's just a smaller number.
Yeah.
25 and 1/2.
Yes. Oh.
Yes? Thir-
34 is the decimal.
No. 34, no. Because 3/4 is actually this. Oh, okay. What 3/4 is this though? Oh, okay. Okay. Because you were telling me, I thought you were telling me you turned this. Okay, I was like, no. Okay. Sorry, I misheard what you said.
I did the decimal.
I got you, I'm sorry.
I did the decimal divide.
So, yeah, but you could do that. Turn 3/4 into this and multiply this. And then, let's see, that's 20, 17. That would be 28 to 23.
Oh, I see where I messed up.
So 25, 5, and then you would also, and then that's also equal to 25. And
Yep.
so the 0.5, anytime you have 0.5, that's equal to a half.
Wait a minute. It's okay. I'm not a minute.
Oh, mistakes. Those aren't allowed in here because I never make those.
Right.
Jason is you know I'm totally kidding, right? Jason is drawing the floor plan of his bedroom. He is drawing everything with dimensions that are 1/12. Oh, scaling factor again.
Yay!
1/12 of the actual size.
Uh-oh.
His bed measures 6 feet by 3 feet. So if we have the bed, this would be 3 feet, this would be 6 feet. And the room, I'm just drawing out what they're giving me. The room measures 14 feet, because I'm visual, 16 feet. What are the dimensions of his bed and room in his drawing? You may not have needed to do this, but I needed to take the information and kind of draw it out. So, he is drawing everything with dimensions that are 1/12 of the size. So what do you need to do with that information when it's 1/12 of these measurements? What? Multiply what?
16. 16 plus 4, 16 times 14, then 6 times...
They're not asking for the area.
16 times 6. No.
If you're telling me, why would you do that? If you tell me 16 times 14, you're giving me the area of the room. Are they asking for the area of the room?
16 times 112. 16 times 16.
Yes! Because you're taking 1/12 of the actual size. Oh, this was a couple lessons ago. 1/12 of. So it's, you need to figure out the measurements of his drawing. So it's 1/12 of 16, 1/12 of 14. Oh. So you can figure out what it would be in this picture.
You're done multiplying, you add your...
Are they asking you to find the perimeter? So why would you add them? Are they asking for the total measurements or something? No, so why would you add them? Y'all are doing stuff that they're not asking you to do. Y'all were doing that one time on a test. Y'all would take the numbers, you would do the right work, and you'd add everything. They didn't ask you to. So 1/12 of 16 would give you the measurement for this. These are the actual measurements in his room. Demontre, hi. 1/12 of 14 would give you, Hunter, hi. 1/12 of 6. 1/12 of 3. So find those. It is not.
Okay, I've got a lot of things to do here.
Oh, you can do it. What is 1/12 of 16?
12.
16, 12. So that would be 16. 16 twelfths. 1 and 4/12 equals 1 and 1/3.
Yes.
Because if you simplify that by 4, 4 goes into 12 3 times.
Oh, did you simplify that by 3?
Yeah. 4. So where it's 16 feet, in actuality, his drawing, it would be 1 and 1/3 of a foot in his drawing on the piece of paper.
Wait, I do it when it's multiple times. I do 6.
6 is down here. That's not where I am. 1/12 of 14.
Oh yeah, it's going to be
Equals 14.
You're doing 16 over 1.
Oh, darn.
It's
14.
I mean, yeah, no.
14, 12.
1 search is 1 and
1
2
and 2 12.
1 and 1 6.
1 and 1/6 of a foot. So where he's got 14 feet in real life, in his drawing it would be 1 and 1/6 of a foot. This is his room in real life. This is when he's drawing it on a piece of paper. Or a piece of poster board or whatever. One 1/12 of 6. Six 12. 1/2 of a foot.
Yes, you can simplify that by 2. 6, 1/2. And you can simplify it again.
Oh, darn.
So 6 feet, it will be half of a foot, which would just be 6 inches. If I really wanted to convert it, I wanted to go further, but it didn't ask me to. Okay, 1/2 of 3, or 1/12, sorry, of 3 3/12.
You can divide it by 3.
1/4.
Yes. Yes.
Which would be 1/4 of a foot, which would be 3 inches. So on his drawing, what's in red is his real room. What's in blue are the dimensions of his drawing that are scaled down so that he's not dragging his room everywhere. So he drew it on a piece of poster board. So that he's like, okay, this is my room. Here's where my bed is. So he wanted it to be what it would be like in real life, where his room is actually the right size, just smaller. Where his bed is the right size, just smaller in relation to what his room really is. Y'all are like, whatever.